Hello and welcome to this demonstration highlighting the parametric simulation functionality with IESVE software. From IESVE 2024 onwards, the parametric simulation feature is readily accessible at the bottom of the Apache application. This automated parametric simulation allows for comparisons of a wide range of integrated design input parameters targeting one or more outcomes. For example, operational energy consumption, carbon emissions, and energy cost. The range of design inputs are grouped into 5 categories. Here is one that I created earlier. In the first category, site and geometry, examples of parameters may include the annual weather data. For this example, a future performance assessment for a building or site may wish to consider and plan for climate-related risks in the year 2030, 2050, and 2080, whereby future climate stresses may become more prevalent. Others in this first category include building orientation, or shading scenarios, or percentage glazing or window-to-wall ratio, whereby the architectural forms may be optimized to limit unwanted direct solar gain while maintaining satisfactory daylight performance. In the second category, renewable energies, the varied parameters include wind power and solar PV panel area, whereby options may be none, or 50% of the roof area, or even 100% of the roof area. In the third category envelope, the varied parameters include the types of construction assemblies or individual insulation materials. For glazing, parameters may include U value, solar heat gain coefficient, visible light transmittance, or even the control of operable windows. Variations for air tightness specifications of the building envelope is also an option. In the fourth category, internal gains, popular varied parameters may include lighting power density and the daylighting controls of those lighting systems. This will combine the daylight simulation with the energy simulation and account for any previous architectural variations affecting both daylight and energy. Finally, the fifth category, HVAC. Parameters here may include the psychrometric control conditions for temperature or humidity, and of course, the system types. In this example, I'm comparing a VAV system against a dedicated outdoor air system, both with and without an energy recovery ventilator. On the plant side, we're comparing a fossil fuel heating system plus a chiller versus an all-electric reversible heat pump system. Now, we don't recommend trying to generate over a million simulations on your first attempt, so no matter how tempting that may be. If I open a smaller study, this one-tab study, for example, you can see I have 5 total parameters at the bottom of the screen, totaling 432 possible permutations in this model. So let's click Simulate. Now there are options to add fuel costs at this point, and a newer option will include simulation resolution. These 2 faster options on the right will perform simulations for 1 week of the month, and that's typically the 3rd week of the month, or 1 week per season. So that's the 3rd week of the mid-month of the associated calendar seasons. Now these 2 options will perform simulations approximately 4 times faster and 13 times faster respectively. With potentially, in this case, 432 possible permutations or simulations up for consideration, faster analysis may be preferred when considering, is option A better than option B and better than option C, and so on. In other words, the parametric analysis is relative comparisons at this stage. So let's start the simulation. I won't show the whole simulation live, but I do want to explain some of the mechanisms at play here. If, for example, I was to examine the impact of doubling the glazing area, this would require a resizing of heating and cooling loads and of HVAC equipment. Because my laptop has multiple licensed seats and multiple logical processors on the CPU, I can perform sizing calculations simultaneously per design day. For annual simulation, there's more of a hopscotch mechanism at play. All 12 of my logical processors are active, using 4 of them per license seat. When one simulation is done, the processor moves on to the next permutation in the queue. Now, if comparing, say, less than 10 permutations or so, one license seat and up to 4 logical processors should be perfectly fine. However, having multiple seats with multiple logical processors can result in exponential time savings, and even more time is saved if choosing a shortened simulation resolution. Okay, once the simulation is complete, results are presented in a shareable HTML format by way of an interactive parallel coordinate chart. Even a non-IESVE user can be sent this report and they can present it to a client for discussion. So let's role play. Say the entire design team is gearing for a net zero or below zero carbon project. We can select those parameters from what was previously approximately 1,500 variations. That will whittle down to just over 500 possible permutations. Let's say the design team are also gearing towards a low energy use intensity value in and around 50 or so. The architect would prefer to have a higher percentage window to wall ratio. Now what that might mean is shading scenarios are desired. So let's go for the 2x deep option. And now all of a sudden we're down to 96 possible variations. Building owner might not want any wind power on the site, so let's choose 0. That means we need the maximum solar panel area, and now we're down to 24 options. We might have flexibility on building orientation. In terms of climatic analysis, we might look at what's okay for today, but also might want to consider what will be okay for, I don't know, either the year 2050 or perhaps even longer again into both 2050 and to 2080. So at this point, we have only 16 variations. It's just basically a case of selecting one. I'll say maybe 1183 and promote that back to my project. And I'll show you how to do that afterwards. Now, there are 2 other possibilities here, or 2 more outputs rather. One is to save out as CSV data. This gives you an opportunity to create your own customized charts, be it for energy, cost, and carbon, and even do it by energy end use. And then the other one is to open a stacked plot. This is best used for a number of permutations that might be less than maybe 10 or so. And then finally, once a permutation design decision has been made, we can simply click on Apply Run to the model. And I'll do 1183 and hit OK. And that selection will be applied to the live model. And that's it. Thank you for watching this brief video about parametric simulation in IESVE software. For more information about other IESVE features, please subscribe to our YouTube channel or visit the website at iesve.com.